Thank you, Martin. I would also like to warmly welcome you to follow this webinar on Introduction to AFX series. My name is Jukka Okkonen. I'm one of the founders of Specim Spectral Imaging. I'm currently a senior application specialist for airborne applications. When I founded Specim 26 years ago, together with my colleagues Timo Hyvärinen and Esko Herla, we were all working at VTT, a government research center here in Oulu, Finland. We were developing hyperspectral imaging solutions and started already in early 1990s. So we have a very long experience in hyperspectral imaging. I'm currently a member of our applications team where my main responsibility is training the customers, partners and collaborators. Naturally, most of the training is nowadays online, but we hope to combine that again with on-site training after the COVID pandemic. We are also offering training material for dedicated users via our customer community. My main responsibility is airborne applications for both manned and unmanned systems and some specific support cases related to them. My background is in electrical engineering, in computer science and embedded software. A few words about the webinar structure. So we'll start with these preparations and startup for a few minutes. This is followed by the webinar topics, which I will introduce on next slide. In the end, we will have a questions and answers session. My colleague Martin is monitoring the webinar chat where you can post your questions, and in the end I will do my best to answer all of them. Should some of the questions remain unanswered, we will get back to you via email. Here's the webinar topics outline. I'll start with brief introduction to Specim, followed by an overview to AFX series. Then we'll have a discussion about multispectral versus hyperspectral imaging and the benefits AFX series is offering to hyperspectral imaging. I will also introduce the recommended drones to be used with the AFX series and will discuss about the mounting and installation of the system using either fixed mount or a gimbaled mount. We'll also discuss about the cabling and powering requirements about the system and the web user interface for AFX series. I will also introduce the GNSS IMU solution we have chosen for AFX, and we'll discuss briefly about the software needed for AFX data post-processing. I will also very briefly introduce the potential applications for both Veneer AFX10 and NIR AFX 17. In the end, we'll have a look at the hyperspectral and LiDAR data fusion. We also have sample data available for the AFX series for both AFX 10 and AFX 17. Okay, let's start with a brief introduction to Specim. We want to make spectral imaging easier to apply. We understand it hasn't been always like that, since it's required quite a lot of knowledge and technical know-how from the users to apply spectral imaging or hyperspectral imaging. More recently, we have developed applications, methods, algorithms and tools to make it easier for you to apply our technology for your specific applications. As I mentioned earlier, the company was founded 25 years ago, so we are one of the pioneers of commercial hyperspectral imaging.
At the moment, we have 65 employees, so we have very highly skilled international team of professionals working for us. Most of the activities are in Oulu, Finland, but we do have sales offices in Helsinki, Finland, US, and China as well. The company is privately owned and it has been profitable since the very beginning. To date, we have delivered more than 5,000 hyperspectral cameras and systems. So we are one of the big players in the commercial hyperspectral imaging market. We work with multiple different application areas. One of the growing sectors is industrial applications. Waste management is ever important all over the world. So waste sorting and recycling on different materials is becoming more and more important. Another growing area for this type of technology is food-related applications. We are also providing solutions for professional user groups who are working, for example, with plant monitoring, disease and stress detection, and phenotyping related applications. There are also more specific applications areas. One of them are the pharmaceutical and medical diagnostics applications. Remote sensing applications are important for us naturally for the airborne side of the business, so for both manned and unmanned systems. I'll talk a bit more about these applications later on in this presentation. We are currently the only provider in the world who provides hyperspectral imaging solutions for practically all optical spectral ranges, starting from visible all the way to long-wave infrared. Our systems are push-broom imaging solutions. So the simplest ones are the spectrographs, the optomechanical modules. We started with those 25 years ago and we are still delivering spectrographs for some specific system and specific customers. So they are still used. When you integrate the spectrograph with a camera, you'll get the spectral camera. You can further integrate that with different types of scanners to be used either in laboratory or field. Last but not least, we have turnkey solutions for the airborne market, so both manned and unmanned systems are available from us. So one example from the unmanned systems is the now introduced AFX series of instrumentation. So how does a Specim spectral camera work? As I mentioned earlier, our cameras are hyperspectral push-broom type imagers. So they are line scan cameras. So we are scanning the image line by line. So it means that either the target is moving under the camera, as you can see in this illustration in the slide. This is a laboratory setup where we have artificial line illumination and some samples moving under the camera. Another type of setup is, for example, a drone-based AFX system where the drone and the camera is moving above the target. And then, of course, we're using natural illumination, which is solar illumination. Specim AFX series cameras were originally developed for industrial sorting and machine vision applications, but they are now used elsewhere as well. We have FX10 Veneer camera, FX17 NIR camera, and the latest product is FX50, which is mid-wave infrared camera from 2700 to 5300 nanometers. This is a very powerful camera and unique solution which can be used, for example, to identify black plastics, which has been extremely challenging in the past. FX10 and 17 cameras have been used for the airborne setup, where we had the fixed mounting including the camera, a little bit larger computer and GNSS IMU, all placed into a fixed mount and installed into the DJI Wind 4 drone. Very good and stable solution. More recently, we have developed the AFX 10 pilot system where we have FX10, GNSS IMU, a smaller MU-DPU computer, and a tiny SCP system control board to synchronize image and navigation data. So all of this is mounted into a single box. This system was piloted last summer and the results are very good. I will show you some data later on in this presentation. Our next topic is AFX series overview. AFX series is compact all-in-one hyperspectral solution for drone use, and we now have available AFX10 and AFX17. AFX10 is VNR and the AFX17 is NIR. So what we have inside the single casing is either FX10 or 17 spectral camera, small computer MU-GPU, and then we are using Trimble ABX15 survey grade high performance GNSS IMU, and then we'll include also our system control board, a miniaturized version of that for timestamping between the image and navigation data. The camera size is similar for both AFX10 and AFX17. They both weigh less than 2.5 kilos. So what about the features for Specim AFX? We are providing the all-in-one hyperspectral imaging solution in a single chassis, which makes it easy to mount either with or without the gimbal. We have multiple spectral region of interest capability for both hyperspectral and application-specific multispectral configuration usage. Like with all of our airborne systems, the AFX series comes with a fully characterized lens calibration, which models the aberrations for the lens. So we have the calibrated field of view and location for each pixel within the field of view and provide that data as a vector which can be used during the post-processing for accurate georeferencing together with the high accuracy GNSS IMU data. We also have an ability to collect more light thanks to larger aperture of the system, but we still have significantly less smile and keystone compared to competing solutions. So what are the benefits of the Specim AFX series? Because it's small and compact, it's easier to mount that for different drones and you have more selection available. Since we have only one casing, it's very fast and straightforward for mounting and only minimal cabling is required. The AFX series offers us a more compact solution in our high-end product range. And as mentioned earlier, we have a large numerical aperture which allows the efficient collection of light. Sometimes that means more apertures in the image. However, we have the image enhancement algorithm inside the camera which reduces any aberrations, and the combination of large aperture and the correction algorithm results in high quality data. We have an ability to reduce the amount of data by using the multiple region of interest feature and the focus on relevant spectral areas. Data acquisition on AFX series is fully automated and it's following the flight plan, so there's no need to control the Specim AFX during the flight. We simply set the camera parameters and upload the flight plan before the takeoff, and after that the system acquires the data automatically when the drone flies according to flight plan. We do get accurate georeferencing thanks to our high-performance GNSS IMU solution. And since the IMU and camera are within the same chassis, even if we have to dismount and remount the sensor, there's no need for a new bore side calibration. And should you have both sensors, AFX10 and AFX17. It's very easy to swap between them in a mounting since they have the same form factor and size. On this slide, I have the side-by-side comparison of AFX10 and AFX17. The spectral range is naturally different because one is Wiener and the second one is NIR. They can both acquire up to 224 bands. Of course, the spectral sampling and resolution are slightly different because of the different spectral range. The number of spatial pixels for the Wiener is 1024 and for the NIR 640 pixels. The field of view for both cameras is the same, 38 degrees. The numerical aperture is large, 1.7. We can acquire data even with the full hyperspectral configuration at rates of several hundred frames per second. However, typically with the airborne drone applications, the frame range are ranging from 50 to 100 frames per second. The dimensions of both cameras are identical. They both weigh less than 2.5 kilos. The accurate weights become available when we have the first units from production. There is a small difference in weight. The AFX10 will be probably 1 to 200 grams lighter than the AFX17, but both are definitely less than 2.5. In an AFX camera, the FX10 or FX17 is connected to small mu TPU computer, which acquires the data on the SSD drive. The camera is triggered by the system control board, and the system control board gets the navigation data and the pulse per second information from the GNSS IMU and timestamps the image data to navigation data. So this information can be used automatically during the georeferencing post-process. So it's a large benefit. Then a slide about the ground sampling versus height. The local regulations and limitations on using the drones vary from one part to another. For example, in Europe, the maximum height you can use for flying the drones is 120 meters. And the same 120 meters or 400 feet is currently set in USA as well, unless there are some exceptions on usage of the drones. So always pay attention what are the local regulations. On this table, I have illustrated the different ground sampling distances as a function of height. So when you fly at 50 meters, your ground sampling distance on AFX10 is 3.5 centimeters and AFX17 5.5 centimeters when using spatial binning by 1. If you bin by 2, your ground sampling distances will be doubled. And when you fly higher, depending on the altitude, your GSD values are from 7 to 33 centimeters. So it's the GSD is changing linearly as a function of height. We always provide a spreadsheet for calculation these values accurately for each system. Then the MROI, multiple region of interest. So the MROI reduces amount of spectral data. For industrial FX cameras, the main motivation is to reach higher frame rates. But for AFX cameras and airborne systems, the main motivation is to reduce amount of data from hyperspectral to multispectral for specialized applications. On the left, you can see the full hyperspectral data. With MROI, you can define the multispectral band configuration, specifying any number of bands, band locations, and bandwidths. And then only those active bands are acquired in your data cube. Then multispectral versus hyperspectral. So the one on the left is a typical multispectral configuration where the bands are located on certain fixed, discrete locations. The bands are relatively wide and you cannot customize the locations easily, certainly not before the missions. So these are good for some specific applications, but for others, it's not easy to customize them. When you have a hyperspectral dataset, it provides you data on all the spectral bands within the range. You get highly accurate, narrow spectral bands. You can use more sophisticated algorithms, hyperspectral algorithms for processing and finding the most interesting locations for the spectral information. So the data for all applications can be found on the spectral range. When using the AFX multispectral configuration based on the MROIs, we can easily define any number of bands, band locations, and bandwidths. So it's very easy to configure and define the most optimal configuration of bands for your specific applications. With the fixed band multispectral, you can easily miss information on some specific locations, but with AFX, you can study it first with the hyperspectral configuration and then set the band of interest to certain location where you really have that information related to your application. So that's a huge benefit. Okay, then a few words about the recommended drones for the Specim AFX series. So the AFX series is not designed or dedicated to be used with any specific drone make or model. It can be used with multi-rotor or fixed-wing drone having the capability to fly a reasonable amount of time and payload. So with the AFX series camera and gimbal, the payload is about 5 kilos, and with a camera only, it's about 2.5 kilos. Let's have a look at first the multi-rotor drone with the gimbal. As I mentioned, we are not tied to usage of any specific drone, but we do recommend free-fly systems, Alta X or Alta 8 Pro, with the MoviPro gimbal for gimbaled mounting. With the AFX and gimbal payload, you can fly about 30 minutes with the Alta X Pro. We have used DJI drones in the past, but now there are some question marks at the end of them because there has been some challenges on the availability and delivery of them. Last spring, we learned that both Win4 and M600 were put to end of life, but then suddenly at the end of the summer, they became available again in China. However, there are some issues, for example, with Win4, which cannot be imported to Europe due to conflicting with the ROH2 hazardous material regulation of the EU. I've learned that they plan to have some modifications in Win4, but when will that happen is still a good question. And I guess the same more or less applies to M600 Pro. It's still widely used all over the world, but whether the new models are easily available is a good question as well. Then multi-rotor drone without the gimbal. You can still use the free fly drones without the gimbal and AFX camera mounted fixed on that. Then you get more flight time with Alta X, about 40 minutes. The other potential candidates from different manufacturers are then of course the M600 Pro, which is still widely available. And without the gimbal, the payload of 2.5 kilos is a reasonable amount, allowing you to fly a relatively long time. With the gimbal, the payload is rather close to maximum, and we do not recommend that. DTI is also about to introduce a new model called M300, which has a payload capacity of 3 kilos. That might be an interesting option for the AFX series. So without the gimbal, the AFX can be used with the lower payload drones. But when you don't have the gimbal, you need to plan more overlap between flight lines, especially when flying under windy conditions. So you need to pay attention to that. A third option for mounting AFX series is a fixed-wing UAV. One candidate is from a French manufacturer called Delair. They have a model DT26 open payload, which has a capacity of up to 3 kilos of payload with a reasonable size, so we can fit in our AFX camera into that. These fixed-wing UAVs are intended to be used with larger areas compared to multi-rotor drone coverage, and they can fly autonomously on those areas, so that might be an interesting option for that type of applications. Then about the mounting and installation of the AFX series. Let's first have a look at the IMU body frame, center of mass, and entrance pupil. So this is important information for the camera when you start to use it. So you need to configure the location of the IMU and then use the center of mass location when balancing the payload in the gimbal or even in a fixed mounting. And then of course the entrance pupil location is important when you define where the navigation solution should be valid. This information is for AFX 10, and then we'll have the similar information for AFX 17. Then mounting the AFX series with the FreeFly MoviPro gimbal. FreeFly is providing a set called aerial bundle for MoviPro, so that includes the gimbal and a landing gear. You can attach this system easily using a quick lock to Alta X or Alta 8 Pro drones. So the balancing of the AFX camera payload in the gimbal is straightforward, and you can easily use either AFX 10 or AFX 17 since the dimensions of them are the same. When you do not have the gimbal, the mounting of the AFX series is still straightforward. We have 5 mounting holes on top of AFX camera. You don't need to use all 5 of them. Maybe it's enough to use 2 or 3 of them. So by using a simple carbon fiber adapter plate, it's possible to mount the AFX series sensor easily to a drone like a DJI M600 Pro. There are additional 4 mounting holes at the bottom of the AFX camera, but these are not typically needed for the drone-related mounting. Then the cabling and powering. Since we have an all-in-one solution, most of the cabling is already made inside the camera, so we need only minimal external cabling. What we need is a GPS antenna cable for the AV14 antenna that is attached to the drone. Then we need a power cable. We can take the power either from drone or from gimbal, or use an external battery for the AFX camera. Then the third connection is the Ethernet connection for the web UI. This will be used only on the crown to configure the camera parameters and excuse me, to configure the camera parameters and upload the flight plan. So that is not needed when the system will be airborne. Our next topic is AFX operation. We have automatic in-flight operation for the system. So the laptop and the web user interface are used only before the takeoff to set the camera parameters and upload the flight plan for data recording. There's a mini ground station feature inside this AFX sensor which will control the automatic recording. For the automatic recording, we have the drone flight plan, which is shown in blue in this illustration. There is overlapping Specim AFX flight plan on top of it, which includes the flight lines with starting and stopping point for them. So whenever the drone is executing the flight plan and it bypasses a green starting point, the recording starts. And then when it flies via the yellow ending point, the recording stops. And the same process continues for each and every one of the flight lines. So the system will automatically record the data and they will be available for download after the mission from the AFX sensor. A few words about the web user interface on AFX camera. We have different control permission levels for the field operator and then the field moderator. There will be more information available on which features are accessible in the AFX camera in AFX series user manual when that will be released. On the camera parameters, we are controlling frame rate, exposure time, and spectral and spatial binning, and set the parameters for recording of the image and navigation data. Flight plan for the AFX sensor is uploaded in KML format. In this example, we have 3 flight lines, so this is obviously a bore site, a flight plan, which is typically the first flight that is made with the new AFX sensor. The GNSS IMU unit in AFX camera is APX15 UAV, so this is survey grade GNSS IMU with high performance. We can use either the real-time navigation data or the post-process navigation data from the unit. We have a system control board called Tiny SCP in the system, the AFX sensor. SCP board will trigger the FX camera. It reads the navigation data from GNSS IMU and receives the PPS pulse, and based on that information it timestamps the image to navigation data and embeds the timestamps into the navigation data stream to be used later on during the post-processing. For the post-processing, we need 3 tools. The first is Specim Calibre Pro for radiometric correction and georeferencing. The second one is Applanix Postback UAV for navigation data post-processing. For atmospheric correction, we can use either ATCO from Resay or FLAS or Quark from Harris. These are plugins for Envy. It's also possible to have wide reference targets placed in the mission area where the data is acquired, and this can be used for a rough estimate of reflectance. Our next topic is potential applications for Specim AFX series sensors. I've listed here some potential application areas for the Veneer AFX10. Most likely, the most potential applications are related to vegetation, species identification and classification, and some vegetation stress related studies. Also, some application areas can be found in the precision agriculture on studying some nutrients, drought, fertilizers, and for example crop yield. Of course, some other potential applications exist as well. When moving into the NIR range and using the AFX 17, some new applications are introduced. For example, soil properties related applications and analyzes the organic carbon, soil moisture content, contamination and heavy metals, and studying the nutrients like total carbon and total nitrogen are becoming more important. On vegetation species identification, the NIR range provides more deeper information, for example, on the leaf structure. And we've all heard in the news during the last year or so that the forest fires are becoming more common, for example, in Australia and US. AFX 17 can be used to analyze active or starting fires and also the burned areas and fire affected vegetation state. Since the vegetation is most likely one of the most potential application areas for the AFX sensors, I've listed here some potential applications, more detailed specific applications for AFX 10 and also for AFX 17. Unfortunately, we do not have time to go into deeper of these applications, so I've listed them here as a reminder or teaser, if you like.
Okay, our next topic is the hyperspectral and LiDAR data fusion. I'll start with the hyperspectral imagery. So hyperspectral imagery is auto-rectified. So you want to remove the effects of image perspective, as sometimes referred to as tilt, and then relief, which are terrain effects coming from the variation of the ground elevation of the Earth. So in order to do that, you need to have as an input an image which is having very accurate sensor geometry, which means accurate GNSS IMU unit. You also need to have an accurate elevation model of the ground surface. Different type of ground elevation models are, for example, digital elevation model, which represents the bare earth elevations. Then there's a DSM, which is digital surface model, which includes the first surface elevations. This is typically coming from LiDAR. We'll discuss a bit more about that on coming slides. There are some sources for ground elevation, public sources, which are SRTM, so-called shuttle radar topographic mission, which is rather coarse, typically 30 meters or 90 meters. Then there's Aster Global DEM. It's also coarse, 90 meters in most of the locations, 30 meters in USA. There's World DEM, which will give you a bit more accurate DEM from 1 to 30 meters, depending on the area. There are also global LiDAR data sources, which are unfortunately not available everywhere, but provide a bit more accurate resolutions for the DEM. Then the customer's own LiDAR data is the most accurate source, typically 1 meter or even sub-meter resolutions, and that's suitable for usage with the drone type systems. So what is a LiDAR? This is by no means a thorough explanation of the technology, so it's very simplified illustrations for it. So LiDAR means light detection and ranging. The device uses laser pulses to measure the distances that, using the pulses that strike and reflect from the features on the surface of the Earth. So it converts the scanning angle and the distance from sensor information into the georeferenced data points. And it collects typically hundreds of thousands of positions per second into something called a point cloud. A single pulse may strike several features, causing multiple returns, which are reflected pulses. So for example, in here, when the laser pulse hits the tree, the first reflectance comes from the top, then there may be additional reflectance from the side, and then finally reflection from the ground surface. So these 3D point clouds are typically huge. They are colored by height and reflect pulses from the ground, roads, buildings, power lines, tree canopy, you name it. One of the typical products is that it maps the bare earth beneath the vegetation. So how they use the LiDAR data? High-resolution bare earth surface, or DEM, is one of the most typical ones. You can have roads, structures, and other surface features included. On vegetation applications, you get the canopy closure and structure and tree and stand heights. So typical LiDAR data products on so-called LiDAR language, if you like. Bare earth surface, which is the high-resolution DEM. Highest heat surface, which is the high-resolution DSM. And then the raw point cloud, which is basically a 3D visualization. And for specific applications like forestry, you can get additionally first order derivatives like canopy height, cover or density, and some additional forest inventory parameters. It's important to realize that LiDAR alone cannot classify all species, so the hyperspectral imaging can do that. So LiDAR assists by adding more spatial details both horizontally and vertically, improving the accuracy of the classification. Typically, some sophisticated algorithms like support vector machine, extreme learning machine, random forestry are used together with EPs for data fusion. EP is extinct profile, which is basically a collection of specific feature sets. Then a simple example for hyperspectral and LiDAR data fusion. This is a forestry application. So you first create a digital surface model from LiDAR data and resample that to same resolution with hyperspectral data. Then you use that for auto rectification of the hyperspectral data. You classify the targets using whatever methods you like, then create tree lists with associated spectra for each tree and assign species to individual trees. And you overlay the hyperspectral data on surface model for illustration, like we see here on the top right corner. In forestry application fusion data, you can use that, for example, for estimation of tree height and volume, species identification distribution, biomass, tree health conditions, and then, for example, stress related to insect attacks on an individual tree level, which is very important application for some specific areas. Okay, the last topic is the sample data for AFX series. We do have sample data for both veneer sensor AFX10 and NIR sensor AFX17. Should you be interested in receiving a sample, please contact us and we will get you further details on how to have that data accessible for you. Okay, that concludes the topics for the webinar, and the next part is the questions and answers. I'll hand it over to you, Martin.